So this algebraic method is going to begin with assigning a name or a letter to each term that is a part of the reaction. In this case, my reaction, I will split it into 6 letters, okay, because it has 6 terms, okay. This is going to be my compound A, sorry, B, C, D, E, F. So I'm going to assign a letter to each term, and then I will list the elements, just like we do when we are balancing chemical equations. The metals come first, then the non-metals, then hydrogen and oxygen. In this case, hydrogen is not part of the reaction, so I'm just going to include oxygen. Now take a look. What I'm going to do now is I'm going to turn each element, I will turn it into an equation, a mathematical equation. So take a look. What you're going to see is the amount of each element that are present in each letter. So for example, calcium, you can see that you have 3 calciums that are located in the letter A. So what you do is, in calcium, you say that you have 3 calciums located at the position A. Okay, you have no more calciums at B, no calciums at C. In D, you have how many calciums?
One.
You have only 1 calcium located in the position D. Okay, so in D you will place 1. But remember that 1 is invisible in terms of coefficients. So you can just write D instead of the 1. And we have no more calcium, so this equation ends up like 3A equals D. If you notice, I made a substitution of the arrow. Now the arrow is just an equal symbol. I'm going to create equations for each element. For example, silicon. Silicon is just in here and also here. And as you notice, I have 1 silicon located in the position B, and I have 1 silicon located in the position D. And to separate, I put the equal sign. Remember, I separate reactants from products. And because 1 as a coefficient is invisible, I can totally delete it, okay? Because it is an invisible one. I will do the same for phosphorus. How many phosphorus I have located in the reactants?
2.
2.
And those phosphorus are in A, B, or C?
In A.
2A. As I don't have any other phosphorus, where I have phosphorus in the reactants, the product, sorry.
F.
How many phosphorus in F?
1.
1F. In this case, 1 invisible 1 is, you can totally ignore it, and then your equation is like this. Okay. Now for calcium, carbon, I have how many carbons in the reactant?
1.
1. Located in what position?
C.
C.
Equals to what?
1 carbon
1
located
carbon
E.
located at E. And 1 as a coefficient is invisible, so you can leave it like that. And now oxygen, which is usually the more complex, it's going to be like the longer equation. So in oxygen, how are we going to deal with it? How many oxygens in A?
8.
8.
8 oxygens located at A. How many oxygens in B?
2.
Plus 2 oxygens located in the position B. Then instead of the arrow, we write the equal sign. About the products, how is the equation going to be?
3 oxygen.
3 oxygens located where?
In
In
D.
D.
Plus 1 located in
Plus
E.
1 located at E and nothing at F. Okay, so this 1E can be totally deleted, and with this you can tell that these are the equations that we are going to use to balance this reaction. As you can see, there are so many equations. We have 5 equations. Now the next step is we need to see what variable is repeated the most amount of times. What variable is repeated the most amount of times? Take a look. A
A.
is 1, 2, and 3 times. B is in here 2 times. C is 1 time here, just 1 time. D is in here, and also here. And E is twice, and F is just once. Okay, so what variable is repeated the most amount of times?
A.
A and D.
A and D. Now we need to choose. Okay, we need to choose A or D. Now I'm gonna tell you. With section 1, we chose D. Okay, the video will be in YouTube. Now, whatever you choose is going to be fine. Whatever you choose is going to be fine. Now, me, Martinez, because this is the way I work, I will choose A because A is in the left. And that's the way I like to work. Now, my students told me D because D seems to be easier. Because as you can see, D is already isolated because here you have invisible ones. Okay? So D seems to be easier. Now, up to you. You want me to work with D or A? Both ways are correct. With A. Okay. You have chosen A. We're going to work with A. The video with D is already uploaded in YouTube if you want to take a look to it. Now that process in D was a little bit longer than expected, but both ways are going to lead to the right answer. So, because we have chosen the variable A, we're going to assume a value for A. You're going to give a number. You're going to say that A is equal to a number. Now, I totally suggest to use small numbers like 1, 2, 3, 5, okay? Like that. That's my suggestion. Now, if you tell me, Miss, I want to work by using 100, okay, use 100. But then in the end, you will have to simplify. And you know, simplifying 100 is it's not complex, but it takes time, okay? So I totally recommend to use small numbers. What number would you like me to use in A? What number do you want me to use in A? Vamos a ver. 20. 20 is very big number. 2 is a nice number. It's a small, honestly, the number I always use is 2 or 1. The reason is the multiplication table of 1 and 2 are, in my opinion, the easiest. And that's why I always begin with 2. The reason why I always begin with 2 is because when I start to balance, in trying an error method, I always try with 2 or 3. Okay? So I totally recommend to use small numbers. 1, 2, or even 5 are good numbers. More than that, okay, 1. 1 is the easiest, apparently. The reason why I don't use 1 is that when I use 1, I get a lot of fractions. I know that you use calculator, but I do that, those additions and subtractions, I do them mentally, so I don't like to use 1. Sometimes I use it, sometimes I don't. Now, do I have a way to know which one is better, if 1 or 2? No, I don't have the way to do that. So I prefer to use 2 and then simplify if I have to, than using 1 and start working only with fractions. That's the way I see it. Sorry if I'm leading you to the place where I feel more comfortable. But I think that if I give you all these tips, you're gonna do better. Because as I told you, for me, if you tell me 1, I can use 1. Perfect, I can do that. But I'm gonna be using a lot of fractions. Now, using 2 doesn't mean that you're not going to use fractions. But I have found that it's easier to work with 2. So I'm going to use 2. If you want me to use another value, because you think, no, usted se va siempre por lo más fácil. Yes, that's the idea. Why do I have to do things more complicated? So using 2 is a good number. Using 1 is a good number, but sometimes, as I told you, you will have to use fractions. So the majority says here 2, 2, 1, 10, 2, 20. So most of you have requested 2, and that's exactly what I'm going to do. A equals 2, and I will start working with this value. So I'm going to number the equations. I'm going to start working with every equation that involves A. For example, the first equation that I have is 3A equals D. Okay? 3A equals D. Remember that we assign a value to A, and we say that A is equal to 2. So if A is 2, then D is equal to 6. So this is the first value that we got. So I'm going to write all my variables beside. I know that if A is 2, I know that D is equal to 6. So I start to write all the values over there. Okay? I already worked with the first equation, so I'm going to work with the second equation. Now take a look in here. I shouldn't work with the second equation because I don't have A. But since I already found D, I can totally use it. Now I totally recommend to follow this. This is my first equation, second equation, and third equation. Because remember, we gave a value to A, so we're going to work only with those equations that have A in the first place. So I'm going to skip this one, and I will do the other equation that says 2A equals F. I will substitute the value of A, that is 2, and this gives me the value of F. So f gives me 4. And now that I know the values of f, I write it over there. F equals 4. Now my other equation that I have is the number 3. The one that says 8a plus 2b equals 3d plus e. I know the value of a, I know the value of d, okay? So that means that I have two variables here. So far, this equation, I cannot work with it because I have two unknowns. So I'm going to leave it here. No voy a trabajar con ella porque tengo dos incógnitas. Okay? That one I'm going to use it in the very last. So now, I already used this equation. Esta está pending, you know. Ahora voy a encontrar this one. B equals D. Since now I already know the value of D, I know that B is equal to the value of D, which is 2. So this will be the other value that I found. B is equal to 2. If I know B, then I can use the equation before. Okay? Now I know B, and I can get E. Okay? I can get E. So now I'm going to use the prior equation to find E. So I say 8a, which is 2, plus 2b, b which is also 2, is equal to 3d, d which is also 2, plus e. This is 16, this is 4, this is 6, plus e. To get rid of this 6 and leave e alone, I will subtract 6 in the two sides of the equation. Okay. Oh my god, sorry, yes. Thank you so much. The value of d is 6, sorry. Here is 6, so 3 and 6 makes 18, plus e, thank you. So this is going to be 20 equals to 18 plus e. And to get rid of the 18, I will subtract it in the two sides of the equation. Okay, so 18 and 18 will be cancelled. And in here, negative 18 plus 20 is going to give you 2. 2 is equal to e. And with this, you find another value. So e is equal to 2. Now in the very last step, I will use the remaining equation. This one I used it already. Now this one. C equals E. You already know the value of E. So you say that C is equal to 2. And now you have all this. Now, what happens after is you need to analyze what kind of numbers you got. Analyze these numbers. What can you tell about these numbers?
That we can divide it by 2.
Exactly. We got numbers, all of them are divisible by 2. That means wait. Sorry, I have to make a correction again. B equals D. Okay, yes. Thank you, Vanessa. I didn't notice. No, 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 no. Es que aquí me equivoqué porque estaba viendo otro valor. This B is equal to D. B is 6. Aquí tengo otro error. Ay. So here is, I wanna do the correction now. B is equal to D. So here is also 6. Pero tengo que corregir esta ecuación. Thank you. I just did one correction. Like this will be 16 plus 12 equals 18 plus E. This gives me 28 equals 18 plus E. As to get rid of the 18, I subtract it in the two sides. And here I cancel this and that. And this gives me 10. 10 equals E. Right? 10 equals E. So E in this case is not 2, is 10. I did the correction already. Now I need to do the correction of C. Esto fue lo que me faltó corregir, pero no corregí el resultado. That is 10. C is going to be 10. Vamos a ver. F sí está bien. C también. Okay. Okay. C. Now I did everything good. And again, you see the numbers and you will notice that all of them are divisible by 2. Sometimes these numbers are going to be divisible by 3 or by 5. Okay, you have to be smart enough to know that. And because all these numbers are divisible by 2, we're going to divide it. Okay, so every number should be divided by 2. So A is not 2 anymore, A is going to be 1. B is not 6 anymore, B is going to be 3. 5, 3, 5, 2. And these values that you see right here are all the numbers that you will put in the reaction. Because I arranged it in order A to F, okay, I'm going to write the numbers just the way that I got. 1, 3, 5, 3, 5, and 2. And with this, the equation is already balanced. Sorry about all the mistakes that I did. Now, to check if everything is balanced, you know that you can compare whatever you have in the right with whatever you have in the left. So if you're not sure if you did everything right, you can just compare. So I'm going to do it now because now I don't feel confident because of the many mistakes that I did. So just to compare, I have 3, 3, I have 3 and 3. I have 2 phosphorus here and 2 in the right. I have 5 carbons in the left, 5 carbons in the right. I have oxygen, I have 8 plus 6, so I have 14. And in the products, I have 9 plus 5, that also makes 14. So with this, I can tell that my equation is balanced. Now, imagine that I have ended the exercises with the mistakes I had. If I do this process, if I just do the check, I would know that I had a mistake and that I could do the correction. If I don't do the check, if I assume that everything I did was correct, so I'm taking the risk of committing mistakes because sometimes we're not aware of the mistakes that we make, just like happened to me right now. So I always recommend to check everything. Even if you trust yourself, doing the check is not going to take more than 2 minutes and it's going to make you feel confident. Now, with the other section, I did the same exercise, but we started by assigning a value to D instead of A. In the procedure with the other section, it got more complex, but in the end, the answer was the same. So I recorded the two ways. You will notice that with the other section, I had to use fractions. It was more complex for them, but in the end, easy or complex, the answer was the same. That means that this method is good. Okay, it's good if you don't commit mistakes, it's going to be good. And sometimes we're going to have some exercises that are more difficult to balance, and this method is very trustful. So trust the process. Even if the process is longer, it's good. Now, as a homework, you will do these 4 exercises here. These equations look big, but they're not too complex to balance. I already did them all. Okay, so of course, you will do this homework by using this method. And in the platform, I will send you videos from a guy explaining this topic. Those videos are in Spanish, but to be honest, I don't care if you watch the videos in Spanish, as long as you understand the procedure. So remember, you don't need that I tell you if you did it right, because when you balance the equation, you can do your own check. So do your own check to know if you did it right or wrong. And in the PDF file, you will see the 2 procedures, section 1 and section 2 procedure, but the answer is going to be the same.